I'm going to explain about the usage of lock and grub. Lock and grub of sequencer in UVM. Lock and grub will be helpful to lock a particular sequencer by the sequence. If multiple sequences are trying to get this particular sequencer, with the help of lock request and grub request, you can able to lock or grab that particular sequencer. Okay. A lock request is put in the back of the arbitration queue. This arbitration queue is present inside the sequencer. When you give this lock request, that will be put in the back of the arbitration queue. The lock request will be arbitrated the same as any other request. First, before when I give the lock request, it will be put in the arbitration queue. Before that, we have some other request, right? So this request are processed when this lock request happening. At that time, this particular sequence will lock the sequencer. Lock is granted after all the earliest requests are completed, and no other lock or grub are locking the sequence. The sequencer is not grub or locked by any other sequence. Then, if all the processes are completed, now currently we are applying a lock request, so it will lock the current sequencer. A lock is a blocking task, and when access is granted, it will unblock. If no argument is supplied, like this, if I use just a lock off, okay, the current default sequencer is chosen. And unlock, the unlock sequencer function is called from within this sequence to give up its lock and grab. Already sequence locked a particular sequencer. To unlock, you give unlock request, it will release it, so that other sequence will get the sequences. In the same way, we have a grub. So this grub request is put in front of the arbitration queue. That is the difference. Here in lock, the request is put back of the arbitration queue. So before the previous request what is there in the queue, that will process, then it will take that lock request. But when you give this grub request, it will put in the front of the arbitration queue. A grub request will be arbitrated before any other request, so it will take place immediately. A grub is granted when no other grub or lock are blocking this sequence. Okay. Before that, there is no pre-exist lock or grub. Okay, so that it will get as soon as when we apply this request. A grub is blocking task. If no argument is supplied, then the default sequencer will be chosen. But also, if you didn't mention a sequencer, particular sequencer, it will take the default sequencer. Ungrub is very similar to unlock. It will give up the sequencer so that other sequence can able to access. Let's see one example. Class simple sequence extend UVM sequence. It is a type of sequence item. Sequence item REQ is a handle of sequence item. Using this, we are registering simple sequence to a factory. It's a default new constructor. Okay, we have to create and we have to call the super.new here, and task body method. Here we are using that lock of the TQVM to REQ. So it will perform all the process create, okay, and start item, randomize, okay, send and finish item, everything will do with the help of this macro. After that, giving unlock. Here in this example, Okay, here we are including the UVM package. We are importing content of the packages here, everything. Here we have one enum type. Okay, that I typed it. So this inst is a data type, enum data type that contain all these elements: push A, push B, add, sub, mul, div, popc. Inside a sequence item, we are instantiating inst as a type of inst that is declared as a random. Then we need to register this sequence item and the fields into the factory here. So enum, so we are using the UVM field enum, and this is the variable name. Okay. First one is a type name, so this variable name, and this is the flag we need to set. The new constructor, the latest version of UVM, we need to explicitly mention this default new constructor, and we need to call the super.new. Since it is a object, just name is enough. Else we need to pass the parent also. And here we have one function convert to string. So this will be convert the send value to a string with the help of this inst.name. Inst is a enum type. It contains all these elements. So in the sequence, we are assigning some values or some name for this inst. Okay. To print that, we have this convert to string. When I call this function here, this is the output argument function name using $s format of. We are printing this in string format. Here we are using the method inst.name. In enum, associated methods inside that we have name, it will print the corresponding name. Then sequencer, my sequencer is extends from UVM sequencer. It is parameterized with my sequence item. This factory. Then we are calling the constructor new. Then in driver part, my driver is extend from UVM driver. This also parameterized with the sequence item type. And here we register that to factory in constructor, and in run phase within forever with the help of this sequence item port. Sequence item port is the default TLM available in the driver. Okay. Dot get next item, some method. Using that method, we are pulling the request. Request is nothing but the handle of the sequencer. From sequencer, we are taking the request here, and we will just display with the help of that convert to string. Inside the sequence item, we wrote this convert to string, right, that we are calling here. What it will do, it will print the corresponding name what we assign the sequence, that name. Here you can get it in the driver. And after that, we need to call this method sequence item port or item done. Then in agent, we need to make the connection between the sequencer and driver. So we have to instantiate the sequencer and driver. In build phase, we need to create it, and in connect phase, we are connecting sequencer and driver using connect method. Then here these are the sequences. Class sequence A is one sequence. It is extended from UVM sequence, and it is also parameterized with my sequence item. Okay, here, okay, sequence item handle RUQ we created. Okay, then this is set to the factory with the help of the UVM object details and new constructor, and inside the task body, you have to implement the actual sequences. Okay. So here, tick UVM do with it is a, you just pass the constraint. Okay, automatically it will perform all the process. 4 times we are going to do. The constraint we are applying is inst should be push A. In sequence A, All the times while randomizing, the inst should be assigned as push A. And in sequence B, in task body, inst should be push B. But here we are using lock. After performing this 4 times, we are unlock it. Then sequence C, the constraint we are passing is inst should be pop underscore C. Then this is the virtual sequence. Virtual sequence is nothing but it is a container that holds all the sequence. Okay. Sequence A, sequence B, sequence C, we instantiated, and all these sequences we are creating in the task body. And here after that we need to mention which sequence has to pass to the which sequencer. Okay, this sequence A dot start M sequencer. M sequencer is the handle of the sequencer. What is the sequencer we are mentioning in the test? Okay, here inside the test, the run phase, we need to initiate, right? Sequence dot start sequencer. Here we are mentioning p sequence dot start agent dot m sequencer. So this is the default sequencer. Agent dot sequencer. Inside the agent we have a sequencer that is the default sequencer. So if you just mention m sequencer through that agent dot sequencer, that is the default sequencer, right? So through that the sequences will be passed. Okay, the sequencer dot start that sequencer. Okay, all these three sequence has to pass via single sequencer. Okay. Here I mentioned inside the fortune. So parallelly it is a sequence A, B, C trying to access a particular sequencer, M sequencer. And in test, we need to instantiate agent. Here I didn't create environment. Okay, just create agent is that I create sequencer and driver. We are creating the sequence agent. Okay, here inside the build phase we need to create that agent, and in run phase we need to instantiate this parallel sequencer, right? So this sequence I need to start. That virtual sequence I instantiated as p sequencer, p sequence. Okay, p sequence that I created here. Okay, and inside the rise and drop objection, that p sequence dot start sequencer, where it is inside the agent dot sequencer, and in top within the initial begin, I just call the my task. Okay, inside the run task I mentioned my test. My test, when I mention this will be called. Here this in run phase, this sequence dot start, this sequencer will happen. So automatically these sequences will be passed to the sequencer parallelly. Here I mentioned that lock and unlock inside sequence B. So the behavior of lock is it will put on the back of the FIFO queue which is present inside the sequencer, right? So previously first it is sequence A that was put inside the queue. So it is sent to that sequencer. After that B. Okay. So when the sequence B is happening, there we mentioned that lock request. So it will lock the sequencer. Then it will perform all the process. Here 4 times we are randomizing. All the times we are making that inst as a push B. So in the driver, after a sequencer pass to the driver, there we are printing that. Okay, that print we are getting here. So we are getting all the B, 4 times B. Then after that it is unlock. So it is release that sequencer. So remaining sequence getting that sequences. Pop C is happening, then pop push A, pop C, likewise it is happening. Here instead of this lock, if I use grep, Okay, the behavior of grep is it will put in the front of that queue, okay, inside the sequencer. So sequence B will get the sequencer first, okay, then it will see here, it will perform all the sequence of operations, then using ungrup, the sequencer will be released. The remaining sequence can able to access the sequencer. That's all.